Chapter 14, Chemical Equilibrium. So the first chapter, 13, for this class was about kinetics, the rates of chemical reactions. The speed of a reaction is determined by the kinetics. The extent of a reaction, or how far the reaction proceeds, is governed by something called thermodynamics. And that's we're going to be exploring some of that in chapter 14. So we're going to be looking at the equilibrium constant, which is abbreviated with a capital K. This is experimentally measurable, and this helps us to quantify how far the reaction goes. And hopefully this idea of equilibrium constant is at least familiar, because we talked about it a little bit in Chem 1A. We did a little bit with equilibrium constants. So if we have a large equilibrium constant, then that means that the reaction favors the products. The reaction goes more in the forward direction. You're going to end up with more products than you have reactants after everything is done. A small equilibrium constant means the reaction does not go forward very far. The reaction favors the reactants. The reaction goes a little bit.
When you say small, is that like less than 1 small, or like?
Yeah, small, we're talking much less than 1.
Okay.
Yeah, like 10 to the minus 3, 10 to the minus 31. Yeah. Large is much larger than 1.
Okay.
So I would consider an equilibrium constant of 5 to be approximately 1, just based on this huge range that we see. Yeah, good question. So we're just going to use the equilibrium constant in this chapter, and when we get to chapter 17, we're going to look at why the equilibrium constants are the way they are. But for now, we're just going to use them. So the first section talks about fetal hemoglobin and equilibrium. So this is kind of interesting. This is, we're going to get a little bit into biology, which I'm not super comfortable with. I freely admit I am not a fan of biology. I have nothing against biologists, but I just do not care to study it myself. So anyway, but there's chemistry in biology. I prefer to think of it as biological chemistry, right? So red blood cells. Your red blood cells have hemoglobin in them. And this is the compound that carries the oxygen. One of the functions of your blood is when you breathe oxygen into your lungs, your blood picks up the oxygen and then carries it through your blood vessels and drops it off at various places that need oxygen. Your internal organs, your muscles, all these things need oxygen to function. So the hemoglobin, we're going to abbreviate HB. Hemoglobin reacts with oxygen and forms this HbO2 complex. And we have double-headed arrows here, which you've probably seen before. This indicates that the reaction occurs in both directions. So we have the forward arrow and we have the reverse arrow. This is a chemical equilibrium. It goes in both directions. Actually, almost all chemical reactions are equilibria. But there are some of them that go so far in one direction or the other that it's not even worth talking about it. So that's why, if it goes very much in one direction or the other, we generally just resort to a single arrow. We're going to see a lot of double arrows in this chapter. So the equilibrium constant K is going to describe the concentrations of the reactants and the concentrations of the products at equilibrium. And what we'll see is that equilibrium systems respond to changes in ways that maintain equilibrium. And that is Le Chatelier's principle. A system in equilibrium will respond to changes in a way to restore equilibrium. And, I'm a person who, I just don't really like change that much. I'm not a big fan of new things unless it's my idea. So sometimes new things get imposed on me, right? It's like an equilibrium chemical reaction. It's gotten everything settled out just the way it likes it, and then you go and you throw more reactant at it. It's like, I don't like that. And it's going to react to that, respond to that in a way to try to make things as much the same as it can. So it just kind of resonates with me, this whole idea of equilibrium. So So back to the oxygen business and the blood. So in your lungs, you have a relatively high oxygen concentration. And so that causes this equilibrium to shift to the right. And so the hemoglobin will bind the oxygen. And then the blood with that bound oxygen travels around and it comes to your muscles, which are low in oxygen concentration. So now the oxygen concentration is low. Well, that has messed with the equilibrium. So the reaction will shift to the left and release oxygen. So it's a really awesome system. As the blood flows to the muscles, it releases oxygen. It keeps going, it comes to the lungs, it picks up more oxygen, and it's like this supply river or something that goes around and picks up oxygen and distributes it. Yes?
Is it almost like osmosis?
It's a little like osmosis, but it isn't. There are some similarities with osmosis.
So you say like high concentration, low concentration?
Right. Osmosis does involve opposing factors where you have solute molecules going through a membrane in one direction and going through a membrane in the other direction. And so there is a bit of an equilibrium that happens there. But here we actually have a chemical reaction occurring and not just things moving between a membrane.
That makes sense.
Yeah. So, do you guys remember Le Chatelier's principle? No? So, you remember the name. Well, that's a step, right? Because you did learn about this in Chem 1A. So, let's just review the idea here a little bit. So, here we have an equilibrium. And if we throw in extra oxygen, the system says, oh, hey, you raised the oxygen on me. I want to do something to make the oxygen lower again. I liked how it was. Well, the only thing it can do is cause the forward reaction to occur. That will lower the oxygen. Now, that also lowers the hemoglobin, and it raises the hemoglobin-oxygen complex. But it can get back to a balance. Okay, so that's the basic idea. And then we're going to look a little more about exactly what's going on. Do you ever wonder, how does an unborn baby get oxygen? Babies are human, right? They need oxygen, but they're not breathing when they're in utero. The mother's blood has oxygen in it, but that blood doesn't actually mix with the baby's blood. Well, it turns out that babies have what's called fetal hemoglobin. It always looks almost like fatal hemoglobin, but it's fetal. It's the hemoglobin of a fetus, which is very similar to our hemoglobin, but it's a little bit different. It has a larger equilibrium constant. So, larger equilibrium constant means that it favors the products more. You have a question?
What makes it have a larger?
I don't know. What makes it have a larger equilibrium constant? I do not know that off the top of my head, and your book didn't mention it.
Is it like something on the web?
We could look it up, I'm sure. Yeah.
Why don't we keep that like keep like full adult channel?
That's a good question, too. Why does it change? That's a very good question. And how does it change? And how does your body know to change it? I'm sure there's a series of chemical reactions that tell the baby's body once oxygen starts coming into the lungs, hey, we don't need this version of the hemoglobin anymore, quit making it. There's all kinds of things that happen like that. So good questions, I don't know the answer to those. So it forces, because the equilibrium constant is higher, it will go more toward the product. So that means that with less oxygen, you're going to have more product than you would with regular adult hemoglobin. And so what's happening here you've got the baby and the umbilical cord, and the blood's flowing through here, and it's going to the placenta. And in the placenta, you have the baby's arteries and veins, and then you have the mother's arteries and veins. And they come very close to each other, but they don't actually mix together unless something happens. But generally, they do not mix together. So what happens is the maternal blood comes in here with oxygen in it, and the fetal hemoglobin basically takes the oxygen from the mother's hemoglobin. And so the mother is able to hand off oxygen to the baby's blood, even though the blood doesn't mix at all. And that's one of the reasons that pregnant women are out of breath all the time. Because you need more oxygen because you're losing some of it to that little parasite inside you. I have a little bit of a distorted view on pregnancy because I did it 6 times. And, after the first couple of times, the novelty is completely worn off. And you're just ready to fast forward through that. Anyway, equilibrium constants in babies.